Hi guys, so that's going to be the demo I did in class. Just want to show you how a motor works. So that's a handmade motor. So you have a strong, that's the loop here. So here you have a very strong magnet. So it says north. So the magnetic field goes from the top up, right? So the magnetic field is about uniform going up. And here you have a loop. And of course, you do not have any current flowing. But when the loop is going to be positioned in this way, so you're going to have so I'm going to leave it like this, you're going to have a current flowing, right? So here I have a long-term battery. It's only 6 volts. I don't know if you can see the 6 volts somewhere. It's 6 volts. It's a 6-volt battery. But what's special about this battery is that it delivers a lot of current. And when you are working with coil, that's what you want. You want to have a strong current. So if you have a 9-volt battery, it's not going to be as good unless you have two 9-volt battery and you have them in parallel. So the current is going to flow here in the loop, right? So remember with your right hand, you see, let's say the current is going to flow in this direction, right? So it means that little loop here is going to behave like a magnet, right? And with the north in this direction. So there will be a torque applied such as the loop will rotate, and now you see the north of your loop here, it's like an electromagnet will be up, away from the north. So it's going to align itself with the magnetic field from the permanent magnet. At that point, the loop is losing contact. You have no more electricity flowing. So it stops behaving like a magnet, which will keep rotating. If it does not lose contact, right, what's going to happen? It's going to be stuck here, right? And because it wants to stay there. So the way it's done is that so this wire here is all varnished. It's enamel wire. On one side, it's all sanded out, so the varnished is removed. But on one side, I don't know if you can see, one side it's not sanded out. Okay, so the varnish is still there, but there it's sanded out. So at some point it's going to lose contact, so that's why it keeps spinning. Okay, so again, there will be a torque applied such as it wants to align the normal vector here with the magnetic field. But because it's losing contact, it will keep spinning. So I just want to show you that. I have a small switch here, and I'm going to close it, and you see how it spins. So this one is handmade. You can get those very strong magnets online. I think there are three of them stacked together. Okay, now if you want to, I have one that was already built. Okay, that's actually a gift from a student from last semester. So this one is supposed to spin faster because now you have two coils. Okay, so and here you have a magnet north and south, but that north here will magnetize one side, so that will be north here, and that's gonna be south. Those two here will behave like individual magnet. They are electromagnet, right? So what they want to face. This is north. It wants to face south. So that's going to be south, it wants to face north. But because you have two coils, that will make twice the momentum. So it's supposed to go faster, right? So let's see if I have to connect here, I think. Sometimes you need to give a little bar, and it has inertia, so it keeps spinning. So the reason why it's moving faster because now I have twice the momentum, kind of. And then I have another one that I got in the kit, but this one is very tiny. However, it's still interesting because I don't know if you can see, but you have three coils, right? So it's three times the momentum, right? And you still have the north on one side and the south on the other side. So it works like that one, except it's very tiny. So let's see if it works. I'm going to connect it. And they are all DC vectors, so at some point they need to lose contact, otherwise it will get stuck. So of course the fact that it's small, so it has less inertia. Do you remember if you want something to rotate, okay, the inertia, you have to find the moment of inertia, so less mass, less inertia, and it has three coils. Do you really see how almost they work? Okay? And then if you want to get extra credit, very easy, you can build what we call, and I will show you how it works on a PDF, but it's called a homopolar motor. So it's a simple motor that you can build. So what you need a neodymium magnet here and 1.5 battery, so AA battery here. And here you have a wire, copper wire, which is not isolated, without insulation, sorry. So it's not an enamel wire, so you don't want that to be insulated, but you want to have a contact here with the magnet, and if you do it right, it's going to screw. You can have all kind of shape. Now you can find tutorial for that. I will show you in a moment. And that's a student, okay? I'm not taking the credit. It's a student who did that for last semester. This one also worked, but there is friction with the cardboard, so it's not very fast. But it works. So just to show you, so how do I show you now my slide? I'm not sure how to show you the slide now. Okay, so I just want to show you the slide. If I go here, it's that's how it works, right? So it's here you just have the battery. Sometimes it's easier to connect to have the battery here on top of a screw, and then here you have the magnet, your neodymium magnet. So electricity is coming from the battery here, and then you see it makes a loop, and you see that the electricity here is flowing in this direction. The magnetic field is going up, so you're going to have a torque applied. Okay, so it's the same principle, except that's a variation. So you can look it up. You can look up motor with a screw, and or you can look up homopolar motor. Okay, you have video or you have tutorial, and another for extra credit, you can build this one, also very easy to make, but in that case you need wire here, small wire with insulation, and it's enamel wire, so that one has to be sanded out, so you remove the varnish, but here you only remove half of the varnish. So very easy to make. So I want just to show you the tutorial for the other one. No, it's the same. Yeah, that's the one I have. Good. Okay, so it doesn't seem too hard to breathe. Okay, that's all the demonstration I did in class.